Yesterday we learned some trig of some special angles. We drew out our axis lines and we learned how to find the trig values for any one of those angles around one of our axis lines. So the 0, 90, 180, or 270 around the circle. Today we're going to learn how to find some trig values of special angles within the quadrants. So when they don't land right perfectly on one of those axis lines. There are only very specific angles we can do that for. In general, we cannot just find trig values for any given angle without the use of a calculator. But there are some specifics that we can do. So you're going to be given an angle. Our first step is going to be to draw that angle. So we learned how to draw angles a couple days ago. That's going to be our first step, is to graph out that angle. Then we're going to connect to our x-axis. Always the x-axis. That's going to give us a triangle. That triangle will have to be some sort of a special triangle. Our reference angle will either have to be 45 or 30 or 60. So yesterday we talked about how to find reference angles. It'll have to be 45 because a little while back we learned a special triangle. 45, 45, 90 has sides of 1, 1, and square root of 2. So that's something we learned a little ways back, and you're supposed to have memorized for a quiz a little ways back. You may have had it memorized and forgot it, or you may have never had it memorized. This will be crucial to being able to do today's assignment, knowing that in a 45, 45, 90, the sides are 1 and the hypotenuse is square root of 2. And our 30, 60, 90, across from the 30 is 1, we have a hypotenuse length of 2, and across from the 60 is a square root of 3. Okay? Those two triangles need to be memorized. There's no way to do these problems without those triangles. So we're going to draw our angle. We're going to connect to the x-axis. That's going to make a triangle. And our reference angle that we talked about how to find yesterday will either be 30, 60, or 45 so that we can draw one of these triangles. If it's not 30, 60, or 45, we can't do it by hand. And I'm not going to give you any trick questions. So on all of your problems, it will be 30, 60, or 45. So if you don't get that, you did something wrong with your arithmetic. Okay? Has to be those values. If it's not, we can't do it. Since we're graphing these on an x and y axis, there's some direction involved in it as well. So some of our sides might need to have a negative attached to them to mean direction. We're not really talking about like a negative length because that doesn't make sense, but a negative direction in a graph, and we'll look at how that would work. Then our final step is we're going to use SOHCAHTOA. So SOHCAHTOA was something you're supposed to have memorized a little while ago as well to be able to do some right triangle trig, and we'll need that here again. So for our first example, we are going to find the tangent of negative 210. So first thing we're going to do is graph that angle. We learned that when we graph an angle, we start at our positive x-axis. A negative angle, we are going to go around in a clockwise direction, 210 degrees, which is going to land me about here. And what will my reference angle be? 30, because 210 is 30 more than 180. So I went half a circle, 180, and 30 more beyond that to get to 210. Then we're going to close down with the x-axis. Always connect to the x-axis. If you connect to the y-axis, you will get a wrong answer. Always connect down to the x-axis. Our reference angle is 30. So this is a 30, 60, 90 triangle, so we're going to label the sides. Across from the 30 goes 1. The hypotenuse is 2, and across from the 60 is the square root of 3. Every time. Across from the 30 is a 1, hypotenuse 2, across from the 60 is square root of 3, every time.
How come the 60 isn't 2 if the 30 is 1? It's like twice as big.
Because when we learned our law of sines, we learned that there is a proportion to it, but it's the sine of the angle is proportionate to the side, not just the angle is proportionate to the side. So we can't just say double an angle makes double a side. Then we need to label some negatives on these sides, or at least think about if some of these sides should be negative. So when we learned to graph in algebra, we learned that on our x-axis, the horizontal axis, stuff on the right is positive and stuff on the left is negative. So we look at our horizontal side of our triangle, and since this one is on the left, that horizontal needs to be a negative. Okay. On our x-axis, stuff on the right-hand side is positive, stuff on the left-hand side is negative. So that x-axis is on the left-hand side in this problem. We need a negative there. For the vertical, in algebra, we learned that going up is positive, going down is negative. So this triangle goes up on the vertical, so that's going to be positive. Okay? So that 1, since it's going up from the middle line, is still going to be a positive 1. The hypotenuse is always positive no matter what it looks like it's doing. Right? It is only the horizontal and the vertical that can be negative. The hypotenuse will always be positive.
Because you can't square root of a negative.
You can't square root a negative number.
Side of the horizontal.
The horizontal side, the flat side, that square root of 3 is on the left. So that's why it's negative. Because if I was graphing that point, that's where our negative values are in our x-axis. Our final step is to do SOHCAHTOA. SOHCAHTOA. SOHCAHTOA for tangent is what? Opposite over adjacent. So we're looking at this tangent part, opposite over adjacent. So then we look at that reference angle of the 30. What is opposite of the 30? 1. What is adjacent to the 30? Negative square root of 3, and that is our final answer.
That's the final answer.
We learned a while back that we're not supposed to leave square roots on the bottom of the fraction because it's considered improper, but when we do trig, we leave them. So we just get to leave that square root on the bottom here for trig.
Do we put tangent of 30 is equal to 1 over, I guess, square root?
Not tangent of 30. You'd want to put tangent of negative 2 times.
Why'd you use sine, tangent instead of sine opposite sine?
Because the question just specifically asked for tangent.
Oh, okay.
So just whichever one it asks for.
So you always do opposite of the reference angle?
Yes, we always consider the reference angle. Yep. Let's do another example. This example has a couple of things happen in it that didn't happen in the last problem. So we're first going to begin by graphing our angle. We learned that when we graph in radians, we cut each half of the circle into the denominator number of pieces. So the denominator is 4. We're going to cut each half of the circle into 4 pieces. That's 8 pieces total for the circle then. Okay. The bottom tells us how many pieces to cut each half into. Cut each half into 4 pieces. 8 pieces total around the circle then. To graph our angle, we started our 0 line. The top tells us how many pieces to go. We want to go 11 pieces. A circle is 8 pieces, and then 9, 10, 11 pieces lands us over here. And we're going counterclockwise for a positive angle. Connect to the x-axis. Makes a triangle for us. What is our reference angle? 45. 180 divided by 4 is 45. Or 90 divided by 2 is 45. So this is a 45, 45, 90, and we'll label our sides. 1, 1, and square root of 2 are the sides of a 45, 45, 90. And then some of these may be negative, so we need to think about direction. So the horizontal side is the one that's on the bottom of the triangle. And it's on the left-hand side of the picture, so that horizontal one needs to be a negative 1. The vertical one is going up from the middle of the picture, so it's going to be a positive 1. Hypotenuse is always positive no matter what it looks like it's doing. Questions on drawing and labeling the triangle?
If it was going down, it would be a negative 1,
Yeah.
right? And then yeah.
So then our last step to solving this problem is to do SOHCAHTOA. In this problem, we're asked to find cosecant. Cosecant is not a part of SOHCAHTOA. SOHCAHTOA is sine, cosine, and tangent. But yesterday we learned about this thing called cosecant. And we learned that it was the reciprocal of one of those 3 trig functions. Which one was it the reciprocal of?
Sine.
Sine. Okay, cosecant was the reciprocal of sine. So if sine is opposite over hypotenuse, and cosecant is the reciprocal of that, what will hypotenuse over opposite? Okay, cosecant is sine flipped upside down, we learned yesterday. So if sine is opposite over hypotenuse, cosecant will be hypotenuse over opposite. Sine flipped upside down. So in this picture, what is our hypotenuse? Square root of 2. What is opposite of that inside 45?
1.
The positive 1. Dividing by 1 doesn't really change anything, so our answer is really just square root of 2. If you left it at square root of 2 over 1, I'm not going to mark you wrong, but we should probably reduce it where we can. Questions?
When you're first drawing the angle, how do you know how many sides or how many lines to draw?
The bottom of the fraction tells us how many pieces to cut each half into. So we cut each half into 4 pieces, and then the top tells us how many pieces to go around. So we counted out 11 of those pieces. More questions? Okay, so for this one, we're going to start by graphing our angle. Graph an angle, we start at the 0 line. This is a negative 150, so I'm going to go around clockwise 150 degrees. Which lands me about here. Connect to the x-axis, always to the x-axis. Never connect to the y-axis.
We've never had a triangle just by chance.
Just by chance, yeah. They could end up in any of the 4 quadrants.
Oh yeah.
How big is our reference angle?
30.
30. 150 is 30 before we get to the 180. Across from the 30 goes 1. Hypotenuse is 2, and across from the 60 goes square root of 3. The horizontal side of this triangle is the square root of 3. Should it be positive or negative?
Negative.
Negative, because it's on the left of the picture. The vertical side of the triangle is 1. Should it be positive or negative? Negative, because it's on the bottom half of the picture. So for the horizontal, we think about left or right. For the vertical, we think about up or down. And this vertical side is flipped down onto the bottom of the picture. The hypotenuse is always positive no matter what. Questions on drawing or labeling the triangle? Yes.
For all of our examples on the homework, will the sine, cosine, and tangent be with degrees and their inverses
No.
with radians?
No, it could be. Yeah, just a minute. It could be any mix of them. What is SOHCAHTOA for cosine? Adjacent over hypotenuse. What is adjacent to our reference angle?
Negative.
Negative square root of 3. And what is our hypotenuse?
2.
2. One more example. We're going to start by graphing our angle, and this one's in radians. The bottom tells us how many pieces to cut each half into. I think thirds are the hardest. Don't draw your y-axis because it's not helpful in cutting into 3 equal pieces. Okay? The vertical doesn't cut a good third. So when you're cutting into thirds, don't draw in your y-axis. Now I start at my 0 line, and I need to go around 16 pieces. Going around one circle covers 6 of them. Go around again covers 12 of them. 13, 14, 15, 16. Put me down here at the bottom. Connect to your x-axis always. How big is my reference angle? 60. 180 divided by 3 is 60. So each of those slices around the circle are 60 degrees.
Is that what you did to figure it out?
Mm-hmm. 180 is half of a circle, and we cut each half into 3 pieces. So 180 divided by 3 gives us 60. Across from the 60 is a square root of 3. Across from the 30 is a 1, and the hypotenuse is 2. Be careful with that square root of 3 and 2. A lot of students get those backwards. For some reason, students want the hypotenuse to be the messy side always, but the hypotenuse is 2 here. Horizontal side is which number? The 1. Does it need to be positive or negative? Negative, because it's on the left. The vertical side is the square root of 3. Does it need to be positive or negative? Negative, because it's on the bottom. Hypotenuse is always positive no matter what. So then we do SOHCAHTOA. This problem asks us for cotangent. So I had a question a few minutes ago. On the homework, will all the radians be the reciprocals and all the degrees be the plane trig functions? No, that just happened to be how these examples worked out. So you could have a degrees with one of the reciprocals. You could have a radians with sine, cosine, or tangent. You can have any mix of radians and degrees and sine, cosine, tangent, or the reciprocals. Okay, it just happened to be that these examples just kind of match those up, but that doesn't have to be the case. So this problem asks for cotangent, which is not part of this SOHCAHTOA. What's it the reciprocal of, though? Tangent. Okay, cotangent is a reciprocal of tangent. So what is its fraction going to be? Adjacent over opposite. If tangent is opposite over adjacent, cotangent is going to be adjacent over opposite. What is the adjacent in this triangle? The negative 1, because we focus on that reference angle, and right next to the 60 is a negative 1, and what's the opposite? Negative square root of 3. You should reduce your double negatives. A negative divided by a negative is a positive, so reduce out those double negatives. You do not need to do anything about the square root being in the bottom of the fraction. It can stay right there, but you should reduce out your negatives. Questions? Alright, your homework is a worksheet in the packet. The first 4 problems are what we did yesterday. So if you haven't done those 4 problems yet, when you get to those, don't try to do them like this because it's not going to work. They land right on one of the axis lines, so that's where we need to use our unit circle that we learned about yesterday. Then problems 5 through the rest are the kind that we learned today. That whole assignment will be due tomorrow. You have the rest of the class period to work on.